First of all, here we have an airplane that is 32,000 feet in elevation, and it's descending at a rate of 480 feet per minute. The plane's elevation is a function of the number of minutes of descent. So based on our previous discussion of is a function of, remember that means that the dependent variable is always a function of the independent variable. So in other words, this is like your y is a function of your x. So that means we'll treat the elevation kind of as your y, and then the number of minutes or the time as your x. And so we're first of all asked here to write an equation that models the airplane's descent. And so it does turn out that this is linear in nature, because at a rate of 480 feet per minute, this plane is changing in elevation, and so that's really just kind of a slope. Now, because it's descending means this is negative in nature, and so we have a negative 480 slope, but then starting at 32,000, specifically when the time is 0, and that's going to correspond to a y-intercept. So it does turn out that y, which is actually the height of the airplane, is going to be negative 480 times the number of minutes that pass, which is x, plus 32,000. So anytime you write an equation, it's really important that you do specify or define your variables. So we'll let x be the number of minutes that pass, and then we'll let y be equal to the height or the elevation, which is measured in feet in this particular scenario. And then that second question is asking, when will the airplane be 10,000 feet in elevation? And so that would be a known value for the feet variable or the height variable, which is actually the y variable. So you should be able to substitute in 10,000 in for y then. And then using this equation, you can solve for the x, which would be the particular time which is going to occur. So if we subtract 32,000, we get negative 22,000 is going to equal negative 480x. And then you can divide both sides by negative 480 then. And that's going to give us that x is equal to 45.83 with the 3 repeating on forever and ever and ever. So basically 45 or 46 minutes or so the plane will be 10,000 feet in the air. And then here seems somewhat similar because it's still involving an airplane. We have a plane ascending this time in elevation at a rate of 2,965 feet every minute. And we also know that 12 minutes after takeoff, the plane is at 35,580 feet in elevation, right? An equation that models the airplane's ascent. And so because we know this rate right here, we definitely know the slope is going to be that. But then we don't know the y-intercept because this height right here was not when the time was 0. It happened to be when the takeoff was 12 minutes into takeoff. But that does tell us then that we know the time and the corresponding height, which means that we know a particular point in the relationship right here, right? So if we know a point, and then we also know the slope of the airplane, we can write an equation for this ascent in point slope form. So we can take y minus y, which is equal to m, which is the slope of 2965, and then x minus x, and that's going to give us the equation in point slope form, and then we can solve this. So y minus 35,580 is equal to 2965x, and then if we take 2965 and we times that by 12, we get minus 35,580, and then you can get the y alone if you add 35,580 here, and then add 35,580 here, and it actually turns out that you had 35,580s on both sides, so it just turns out that actually you just get y equals 2965x, and that should make a lot of sense because that's going to be the slope, the ascent, and then right here is the starting height, which of course the starting height should be 0 right at time 0 because the plane's going to start on the ground when it takes off. Here we have the relationship between the altitude and the boiling point of water is linear, so it makes a line relationship. At an altitude of 8,000 feet, water boils at 197.6 degrees, and at an altitude of 4,500 feet, water boils at 203.9 degrees. So we are asked to write an equation given the boiling point B of water in degrees Fahrenheit in terms of the altitude A in feet. So since it says in terms of A, we're going to treat this really as your independent variable or your x variable, I guess. And that means then your boiling point B is really going to be kind of like your y variable. So since we know at a particular height a temperature and then at another height a temperature, we kind of have really 2 points in this relationship. So we should be able to find the slope if we just kind of use slope formula on this. So again, we're treating like the y's as the boiling points, the temperatures. So really you'd want to take the change in the temperatures and then correspondingly take the corresponding heights, so 4,500 minus 8,000. So when you subtract the top there, you're going to end up with 6.3. And then when you subtract the bottom there, you end up with negative 3,500. And then if you divide that out, it gives you actually a ending decimal of 0.0018. So it seems like that there would actually be the slope, which seems to make sense because there's a kind of a negative correlation between the altitude and the boiling temperature there of water. Then we'd want to know the y-intercept, which we don't really know, so I guess we're going to have to put this into point slope form to write the equation. So the equation is going to have to be y minus some y, so perhaps you might want to use, I don't know, like that point right there, where the height is your independent variable and the temperature is your dependent variable. So y minus y is equal to m, which we just found, and then x minus x. And then you'll have to do a little bit of solving on this. So without me really showing too much work here, I'm just going to do most of this in my calculator. We've got to add 203.9 to that. So when you do get it solved for all of the way, what you end up getting is that y is equal to negative 0.0018 x plus 212. Okay, and that's going to make sense because actually 212 degrees is the boiling temperature of water, but that's like when you're at an elevation of 0. And then that second question is asking what is the boiling point of water at 971 feet. So that's really given kind of your altitude A, which is really the x variable that we have going on here. So it's just a matter of substituting that in for x, since that's what x represents right here. So if you do plug that in, what we end up getting then is we get about 210.25 degrees or so would be the boiling temperature at the height of Becker's elevation. Here we've got a wolf population. In 2013 they were 2211, and then in 2018 they were 2655 gray wolves. Write a linear model that models the Minnesota's gray wolf population in terms of the number of years since 2013. So because we want to use the number of years since 2013, we don't really want to use the years themselves, and you'll see what I mean by that in just a little bit. So first of all, we should be able to find the slope right here, because if we just find the change in the wolves, 2655 in 2018 minus 2211 in 2013, and then 2018 minus 2013, so it's really over a 5-year span. The actual change in wolves over those 5 years was 444. So if you do 444 divided by 5, it's 88.8. So kind of a change of 88.8, an increase over time. Now, we want to write this as a function of number of years since 2013. So what that really means then is that if we think about like this ordered pair right here of 2018 and then 2655, we don't actually want to use 2018 for x, because 2018 is not 2018 years since 2013. What it actually is it's 5 years since. So you really want to treat that as 2655 as a point. And then similarly, you can actually treat 2013 as 02211. So actually, isn't that going to be a y-intercept? So then we actually would know then that the equation for this should be 88.8 x plus 2211, where x is the number of years since 2013, and then y there's going to be the gray wolf population at that particular time. So if we wanted to determine the number of gray wolves there would be in 2020, then we know the year, but since x is the number of years since 2013, we really want to use 7 for x to make a prediction in the future based on the information at this time. So if we put in 7 for x right there, then you'll end up getting 2832.6 approximately. So that'd be the number of wolves. Of course, you can't have a fraction number of wolves, so 2832 or 33 or whatever it might be. Here we have that your phone has only 512 megabytes of memory left remaining. You can take low resolution pictures that require 4 megabytes space of memory, and then high resolution pictures that require 8 megabytes memory of each. Write and graph an equation for the possible number of low and high resolution pictures that you can take. So if we define a couple of variables, maybe x to be the number of low resolution pictures you can take, and then y is the number of high resolution pictures you can take, you know that you're going to have 4 times the number of low plus 8 times the number of y is going to be the memory you're going to use up, and you want that to come out to be 512 overall, right? So then using that, you can really solve this for y, and if you solve that for y, and 512 divided by 8 is 64. We end up getting that particular equation right there. And so if you were to graph this, so suppose this is 10, 20, 30, 40, 50, and 60, and 70, and then same thing right here, 10, 20, 30, etc. Then you could just start at 64 and then kind of go down 1 and over 2 from there, down 1 and over 2 from there, to just kind of get a sketch of the graph somewhat. And so to kind of describe the meaning of the slope and the intercepts in the context of this problem, so the slope right here is negative 1/2, right? Negative 1/2 is the slope. And that's kind of explaining the relationship between the low resolution pictures and the high resolution pictures, right? So basically it's just kind of saying if I go down 1, that's really the number of high resolution pictures. So it's just kind of for every high res, there's really going to be 2 low res pictures that we can take, and that's of course true because low res is 4 and you can fit 2 of those into 8 megabytes. So that's kind of what the slope means. And then ultimately for the intercepts, if you had like 64 right there, that's really the point 064, which would mean you'd have 0 low res and 64 high res. And by using 64 high res, because high res takes up 8 megabytes, 64 times 8 is 512, so you'd be using up your memory card. And so if we kept this line going, then wherever it would cross right there, whatever number that would be whatever number it is, and then 0, which would mean that's the number of low res pictures you could take without taking any high res pictures to completely use up the memory of your 512 megabytes there.